Good morning, everybody. Welcome to our discussion about field coil drivers. I'm Ron Resnick for whatsbestforum.com YouTube channel. I'm delighted to be joined by John Wolff of Classic Audio and Ken Songer of Songer Audio. A little bit of background. A basic conventional cone driver consists of four main parts: a voice coil, a magnet, a suspension, and a diaphragm. When an electrical signal is applied to the voice coil, namely our music, the interaction between the voice coil and the magnetic field generates a force which moves the cone and makes sound. That magnetic field can be created either by a permanent magnet or by a separately powered electromagnet, a field coil. When loudspeakers were first invented, permanent magnets were large and not very powerful and expensive, so the first loudspeakers were actually made with these separately powered field coil electromagnets. As time went on and permanent magnets became smaller and more powerful and less expensive, the electromagnet method actually became largely obsolete for many, many years until the field coil electromagnet concept has been reincarnated by people like John Wolff and Ken Songer and the fellow from Audio Note and Wolff von Lange. So let me introduce our guests. Ken started learning about loudspeakers in his 30s, and he was always interested in loudspeakers, and after doing research concluded that field coil drivers were the best foundation for his loudspeakers. Just 6 years ago, Ken quit his full-time career in software to begin designing loudspeakers full-time, and just 2 years ago, less than 2 years, began demonstrating his S1 and S2 loudspeakers at the audio shows. John got involved in building JBL Hartsfield's reproductions in 1985. He began doing field coil experiments in 2006, and in 2010 at the CES, he demonstrated his first three-way all-field coil loudspeaker. In 2022, he introduced his tube power supplies, and currently the flagship Classic Audio speaker, the T1.5, has been in production since 2015. So starting with you, John, how did you come to realize that there was something special about field coils sonically?
My first loudspeaker in the late 50s was a large console radio that I disconnected the radio from, and I hooked up my ICO mono amplifier to, and that was my speaker to begin with. I thought I was moving forward by getting a 15-inch University triaxial speaker, and yeah, it had more sparkle to it. But I always felt and always left a listening session thinking, boy, if I could have just made that radio speaker, this thing from the 30s, have more extension to it. Well, you know, time moved on, and JBL was, you know, the top dog and pro and in all the stereo stores around. I grew up in a southeastern Michigan, Detroit area, and JBL had a big presence there. Beautiful furniture, I liked furniture, and so I just tried to carry on that tradition and make it better.
Ken, what made you decide that the field coil was the best foundation for your loudspeaker?
So it's kind of funny to think back on it. I chose field coils in part initially because it was an easier place to start, which is kind of funny to think of it that way, because it's been so much work over the years to develop the speaker, and field coils are very labor intensive to make, expensive, more expensive than permanent magnets, obviously. But it really was that I come at loudspeakers and audio from kind of an odd angle, which is I have an artistic
I'm just going to move this a little
background.
closer to you because
I have an art background, and for me, loudspeakers, even when I was just making the cabinets and not making the drivers, were a creative outlet. And it was always kind of rattling around in the back of my mind that one day I wanted to make the entire loudspeaker by hand, the driver, the whole thing. And that started out with trying to determine what the magnetism should be for it. What were the finest loudspeakers in the world using as a choice for magnetism? So starting at the bottom of the object and working my way up. And what I found is that unless I wanted to make permanent magnets, again, trying to stick with the goal of making the entire thing personally myself, It's actually, it takes a lot of electricity and it's very dangerous to make a permanent magnet. So, so there was a real appeal to being able to avoid that and go with a different approach. And with an electromagnet, I was able to achieve that. I could, in some sense, if I was willing to invest the money, make a prototype field coil and not have to confront all of that and get the added benefit of being able to assemble the loudspeaker driver without there being magnetism present during the assembly. And that makes a really big difference too. So what you may not know is a lot of these speakers, especially the high sensitivity speakers that John and I make, they have extremely tight tolerances where that voice coil is sitting in the magnet. And to be able to just, in the gap. And if you're able to turn off the magnetism, that makes that very precise task when you're assembling the entire driver much, much easier to achieve.
They may not know that when a permanent magnet loudspeaker is assembled in a factory, the magnet is not magnetized yet, and the thing is fully assembled and actually held together with now the best adhesives in the world. 60, 70, 80 years ago, the adhesives weren't as good, and they were basically just using the same brown glue that they were using to glue the cones to the frame. And then the speaker is assembled, and so you have no stress centering your center pole inside your top plate and use a feeler gauge to make sure that you've got a very uniform dimension, which in a woofer is about 55 thousandths. Then that assembled speaker with the adhesive set up is taken to a charger and is put on this charger, which has a huge bank of capacity to store energy. Hit the switch and you get a big explosion, and all of a sudden you've got a loudspeaker that can sing to it.
But just one last thing on that is I ended up completing that first driver and I set it down on the carpet all by itself and just played it, and it sounded better than any permanent magnet any driver I'd ever heard. And so I kind of came at it from the back end of, and that's what I've been doing, is I've been trying to explain to myself how it could possibly be that an unskilled hand at the time could have possibly made a loudspeaker driver that sounded that great. And I ended up discovering that the field coil and the nature of that magnetism was in large part the answer to that.
And Ken, you fabricate the spider, the voice coil, all those parts are completely fabricated by you.
I do, yeah. I managed to stay true to my project and created the entire driver by hand, designed the entire.
And John, are your drivers completely made by you as well, the components, or?
The diaphragm that I use in my mid-range driver is the True Extent. It's the only full 4-inch beryllium domed diaphragm being made. And I wanted to get away from fabric and aluminum and titanium. The aluminum is actually better than titanium. The titanium has much more ringing to it, and it's a newer and supposedly an improved over, because you get a little bit more highs out of it. But the old aluminum is definitely perceived to educated ears as being a smoother driver for your mid-range and your lower highs, but it's hard to get over 10K out of an aluminum diaphragm. I'm not even running the tweeters up in my room here with the True Extent beryllium on my mid-range driver, and that thing will measure like 3 dB down at 18K. So if we had a bunch of kids in a room listening to music, you turn the tweeter on, they'd say, "Yeah, I'm getting some benefit from it," but we won't go into the age.
In the way that there are companies that make, or in the business of making drivers like ScanSpeak, and a loudspeaker manufacturer can come along and just buy off-the-shelf permanent magnet speakers. Are there any companies today that make field coil drivers for loudspeaker manufacturers to just install off the shelf, or does nobody make the components for field coil drivers?
Other than us guys that are they're doing them in very small quantities, we are a company and we are in business. But no, you know, there's none of the big guys are doing field coils. It's lightweight and it's high SPLs for pro use and inexpensive. So
There's some out there, but they're all small. They're all small manufacturers, much as we are.
I think we're considered a boutique manufacturer.
Absolutely, yeah. And I would say that field coils in general are. I don't know. I mean, do you know what are the field coils that they use in like Focal's higher end models? I'm not sure what they are, or whether they make those themselves.
Focal is more than likely making.
Yeah.
They're a large enough company, but you can't buy their product if you wanted to build a speaker for yourself.
Right.
You can't buy their components.
That's right.
So permanent magnets and electromagnets both move the cone. Why does the cone being moved by the electromagnet sound different than when it's moved by the permanent magnet?
Permanent magnets suffer from sag. Voice coil moving inside of that gap fluctuates the magnetic field that is surrounding it. The only speaker manufacturer that has a specification of Maxwell's in their specification is TAD. And TAD has a Maxwell rating on their 15-inch woofers up in like the 250, 300,000 range. Think of Maxwell's to magnetic force as amperage is to voltage. The amperage is your current, your strength, and the voltage is what's making that. You can have high voltage like the distributor in an old, an old gas carburetor injected coil car running millivolts to your spark plug. So just the manufacturing of a JBL, and TAD was designed by old JBL designers from the 70s, 60s, and 70s for Pioneer. So you look at one, you look at the other, and if the name wasn't on the frame, you just could attribute it to either one. A field coil has Maxwell's in the millions, and it does not suffer from sag. Now, a lot of people say, well, you can turn your current up on your coil, and you can get more Gauss, which is your rating of your magnetic field in the gap. I have found that, like, the top plate I use on my underhung woofer is 65 thousandths, or no, 650 thousandths thick, basically 5/8 of an inch. My coil is 1/2 of that, and it never moves out of that space. And overhung coil is maybe 1 1/8 inch, 1/4 long, and 1/3 of an inch top plate. So most of the coil is always on. A JBL speaker with that thick top plate comes out of the factory with a Gauss rating of 9,500. In order for me to get 9,500 out of my field coil, I have to run that thing at 24 volts. If I'm watching that cone at 10 cycles on a signal generator, and I start fluctuating the voltage to that speaker, I find that even though it isn't getting its 9,500 Gauss rating at 18 to 20 volts, that cone is reacting differently visually in front of me. At 10 cycles, I can watch and see what it's doing. I don't have to set up a speaker system and put some music on, and does this sound better than that? And so So then you go to, okay, if this is what I'm visually seeing, okay, now let's build a speaker system and let's run it at this voltage and run it at that voltage and see if we can perceive the difference. And Jesus Christ,
You really can.
There you are. That came alive. So it isn't just that, oh shit, you can put a whole lot more voltage into it than get more Gauss gap. Actually not. I'm running less Gauss in that gap than the engineers at JBL thought they should have, but they had to deal with magnet sag.
And if I can add on to that, so the way that I've thought about it, or the way that I try to communicate it to people, is that, while, like, for example, a neodymium magnet can be very strong. In fact, there are neodymium magnets at this show, plenty of them, that are much stronger from a magnetism perspective than the field coils that we run. But it's not just about strength. So when you've got, let's say, a neodymium magnet that it has like 2.4 Tesla in the gap, which is an enormous amount of strength, it doesn't have permeability. It has actually a very low permeability. And what that permeability means in terms of the oscillation of the cone as it's reacting to the signal of the music, John called it sag. It's like a trampoline. So it tries to move the cone in space, but it overshoots it.
Yeah,
and then
you're getting overshot.
That's right.
In each direction, and that is,
and
to your ear, is distortion.
That's right. So another way to think about it, which is a good visual way, is that, let's say you've got a very strong jack and you're trying to lift up a car, and you're able to do that, but you're doing it on mud. And as you're doing it on mud, you can imagine that jack is going to slip. It's going to slip and it's going to sink into the mud. But a field coil, because its permeability, let's say in an Alnico magnet, it's higher. It's like a 5 to a 7 or something. In the field coils that John and I are making, if you measure them, they would measure in the thousands. So that's like putting that jack on concrete. It can move the car. It's not only strong enough to move the car, but it can move it to an extremely precise point in space and return it to a resting state in an equally precise manner, far more precisely than any permanent magnet can hope to achieve.
Let's talk about the power supplies you guys use. John uses a tube power supply. Ken uses a solid-state power supply. John, what made you use the tube power supply, and what are the factors there?
The old timers that are my real reference in the learning curve were just giving me a bunch of shit for running solid-state power supply on expensive speakers. And I was looking at it from an affordability situation. It's hard enough, taking that $30,000 or $40,000 nut for buying the system, and then spending another 5 to 10 grand. And in some cases, Oswald Mills makes a power supply, a single tube power supply. I think they want $14,000 or $15,000 for. And I looked at that, and I just said. And then there was the cumbersomeness of another big device in some woman's living room. You get enough from people. Oh, my wife would never let me have a cabinet that big in my house. And I'm thinking to myself, okay, so for myself, I wanted a Tunger power supply. So I asked to have a power supply built, and I told them I wanted this and I wanted that, and I ended up with this monster that is this wide and this deep for one channel. And wow, it really sounded good, but there was no way I was ever going to put that on the market. So this same guy, I told him, look, if we can't get him down to size, then I've got a great power supply and I can enjoy my music at levels that I never heard before. But what can we do to minimize it? So, and I had to have 2 channels because I wanted my mid-range to drive at 1 voltage, adjustability. I wanted my woofers to run at another voltage, adjustability. Because every one of you would set yours at a different point after listening, comparing, playing. So come back. Now I've got a 20 by 10 by 10, 2 tubes, 4 meters, 2 knobs, and somewhat nice looking chassis to me, and it excited me as much as the Monster did. I used that for a year and a half. I didn't know reliability on tubes, reliability on the construction. 15 months, didn't use a tube. The person that bought my prototypes is still running the original tubes with a full set of tubes that I gave him. But I told him, don't take those out just to put new tubes in. I want to know when those tubes fail. Or the first one. He's had it for 8 months now, so well over 2 years. And I turn my system on at 5 o'clock. I eat dinner, fool around a little while. Probably 8 o'clock at night, I'll sit down and listen to music. And on the weekends, 3 o'clock, 4 o'clock in the morning, I go to bed. And my system is on a lot, and those tubes haven't failed. And they're brand new Chinese tubes. I've got 8 pair out in the world right now. No issue with the supply itself, nor a tube failure. Everybody gets a free set of tubes because I'm only going to be around for so long.
And Ken, why solid state for your system?
To be honest with you, our power supply is developed out of somewhat being adopted by another company who really felt passionately about what it was doing. So, when I began, from the standpoint of not even knowing how a dynamic driver worked, I certainly couldn't make a very intelligent distinction of what kind of power was going to be ideal for the field coil. So in the beginning, I was just running $60 bench power supplies that I could get off of Amazon. And I assumed that it really didn't make much of a difference at all. I mean, electricity is electricity. It's just an electromagnet.
Exactly.
How important can it be, right?
Right.
But then that evolved to, getting into some better off-the-shelf power supplies that I could experiment with. There was a noticeable improvement, easily perceivable improvement in the quality of the sound reproduction for me subjectively. And it was right about the time that I was starting to think about, wow, I mean, I could really turn this into a professional endeavor. The results of the speakers and the prototypes were that good that I started looking for companies around me that I might be able to share the work with. And there was one just about 25 miles south of me in Portland called Whammerdyne Heavy Industries. And they were making some really nice 2A3 tube amplifiers and taking them to the shows, and had developed a really nice reputation in the audio industry. And so I reached out to them, and it turned into what's been a long friendship. So I brought the drivers down, and they had a pair of Pat, who was Whammerdyne, had a pair of open baffle speakers, and I made just a plywood baffle that we could swap out and put my driver in. And he and his partner Matt just fell in love with the speakers. And even without adjusting the crossovers on the open baffles, they sounded amazing. And so, they drew in one of their friends, and the three of them all together decided that as a passion project, they wanted to take this on and make the best power supply that they could for these speakers. And then maybe have a partnership between us to take them to the shows. And it would be a good thing for all of us. And it has turned out to be a great thing for all of us. For me, even though it was possible to start from where I started and with just my own passion and the internalization of some kind of foundational pillars of what it takes to make a driver, I was able to achieve what I was able to. It isn't to say that you can do that with anything. So, at some point, brain surgery is the only thing for a problem, and you either know how to do brain surgery or you don't. And for me, the power supply is where that line is drawn. I don't have brain surgery skills, but the guys at Whammerdyne definitely have them. in spades. And so what they put together was, as they describe it, a very what it does is it removes the overlying AC signal that causes a form of distortion as the voice coil interacts in the gap and shunts it at the power supply. So it removes that potential source of distortion at the power supply, and you don't experience it when the AC signal actually oscillates the cones and creates the music. But yeah, I mean, as far as as far as having made a conscious decision, I'd love to say that I really did. But it really was that as so many things in this journey happened, it was just serendipity that I happened to have somebody in my local area who wanted to devote what ended up to be just hundreds and hundreds of hours into this project, so that they could partner with me and we can take those to the show.
John, how does the sound of your speaker change as you change the voltage on the power supply? What do you hear changing?
It's refinement. It's just strictly refinement.
What does that mean? If I'm listening to a vocalist, I'm listening to my Eva Cassidy playing Fields of Gold, what am I hearing different?
Going from aluminum to beryllium gave me detail.
Uh-huh.
Refinement is the nuances, the attack, the actual note, and the decay of that instrument became this instead of this.
Ken, how do you hear the sound of what's coming out of your speaker changing when you change the voltage?
What that changes in terms of the parameters of the driver and the loudspeaker is what's called its total Q. And what happens when you raise the voltage to the field coil is that the Q goes down. And as you lower it, so say in our power supply, the variability is between 9 and 12.5 volts. At 9 volts, for me, I get a richer, fuller presentation, and as John was saying, it becomes a little bit more diffuse. And then as you go up to the top end, to 12.5 volts, for me, the vocals become a little bit more holographic in the center. The image becomes a little bit sharper for me, and the mids and the highs are a little bit more refined and detailed. There's a little bit more air. But as you can imagine, every system is a series of links, and they all make a difference in terms of what that end sound experience is like. So it sounds by that initial description that, well, of course, that I want 12.5 volts, right? I want that holographic presentation and all that detail that he's talking about. But in a system that's overly bright or just tends towards brightness or glare, it can be really nice to dial down that power level, raise the Q of the speaker, or lower the Q of the, raise the Q of the speaker, and then get that kind of richer, fuller presentation out of it. But I'm right with John. It's a matter of nuance. So you shouldn't expect that in going from 9 to 12.5 volts that it's going to be as radical a shift as, say, using a different tube or swapping out your DAC or whatever, a much larger shift in your system. It's not that profound of a change. It's just a way to take a system like I did this just this morning. So our room sounded a little bit too sweet and dense for my taste with the components that we're paired with. And so this morning,
don't forget the room.
And the
room
right?
is the biggest component in a stereo system.
It is, because you're sitting in a speaker. You're sitting in a speaker
Exactly.
cabinet. So I raised the voltage up to 12 volts, and you could really tell the difference. The vocals are a little bit more forward. They're much more tightly focused, in my opinion.
The big speaker companies, Wilson, Magico, Rockport, YG, none of them are using field coil drivers. Is there any application for woofers or mid-ranges in high-end audio where you think the permanent magnet sounds better?
Not for me. If I was in an uncost-constrained world where I could just make any irrational decision from a personal perspective, everything for me would be field coil, because there isn't any application that I can think of where I wouldn't want to take advantage of a higher quality magnetic field.
Every manufacturer represented here, if they moved to field coil, they would have a better product.
Yes, and they would also radically change the cost of that product because it's so labor intensive to produce.
Well,
the field
I don't know.
coils.
Yeah, there's as a percentage of basis, if it was a mass-produced item, I don't think it would be that radical. But nobody's set up for that anymore. So it's really up to us boutique guys to keep this thing going.
In your speakers, John, why do you use a beryllium tweeter rather than a soft dome or a ribbon tweeter or some other tweeter technology?
Detail. I mean, if you look at the Materion website and the pitchfork information and engineering information that they've got online, you'll see where the resonances and all of that are up there way beyond our hearing limits, and they'll show you what titanium does, and they'll show you. Now, if you add not really a super tweeter, but a tweeter to a fabric dome like Cogent used, like was in the old RCA drivers, you definitely would have to have a tweeter to it, and you'd have to run it down at you probably have to bring that thing in at second order at 5,000-6,000 hertz. I've seen a few of you in my room. I don't have my tweeters working. I got my audio tools on my thing here, and I'm 2 dB down at 20K with big noise. So my wood horn was designed by Bruce Edgar in composition with the throat of the driver, which, no, I didn't just take a JBL driver and take the magnet out of it. My driver's got a shorter throat in it, and my throat of my horn is designed as one unit. And then there's that true extent beryllium diaphragm that's crossed over at 500 cycles, where you're getting an awful lot of vocals still out of, all the way up there. And no tweeter, and I'm 2 BD down at 20K.
Ken, how does your S1X new driver improve upon the original S1?
There are quite a few improvements to it. There are three that I would point out. One of them is the motor housing itself. So, you've got that big coiled wire that's sitting on the inside, and then you have the steel that you see, the exterior of it. We switched over to a lower carbon steel. That improves that permeability that I was talking about. You get better saturation of the metal. And then one of the biggest changes that we made is the pole in the gap is made of a metal called permender. Hopefully I'm pronouncing that right. Permender. And that has the highest flux saturation of any metal commercially available. And it's made an enormous improvement to both of those factors of magnetism that we were talking about. The strength of the magnet now at the peak performance that we would recommend for it is 1.9 Tesla now, which is magnificent. And the stiffness of the field is even higher.
It's $19,000.
Yeah. The other big improvement that I was honestly skeptical was going to make a difference in the beginning was I agreed to have our voice coil wires cryogenically treated, and so that what that is it's a 3-day process where they submerge the wire in liquid nitrogen. They slowly cool it down to minus 300 degrees Fahrenheit, and they hold it at that for 2 days, and then they slowly draw it back up to room temperature. And what that does is it compresses the metal, it removes some impurities, and it restores the natural crystalline structure.
Straightens the molecule.
That's right. And what it also does is it lowers the resistivity as a result of the wire. So and then we also switched over from what we had been using in our prior iteration, which is a copper-clad aluminum wire, which I won't go into the benefits of that. There were clear benefits to going that approach. To now a solid, yeah, that's right. Now we're using a solid copper wire, and that's done just magnificent things for kind of the mid-low range of the speaker. Is just much more accurate for me, and those are the two. Or actually, no. There's one other improvement, which is that we also changed the phase plug, which is the kind of bullet-shaped thing you see at the center of the driver, to be solid milled copper, and that has two benefits over the prior aluminum, which is that it dissipates heat from that motor more effectively. We call it a motor because that really is what it is, and it generates quite a bit of heat that has to be somehow addressed, and the copper does an excellent job of doing that. The other thing that it does is that we have found that while a Faraday ring is commonly found in the sleeve of a driver, as a sleeve in a driver that uses one in a gap, we've found that it's effective either just below the gap or just above the gap if you have a sufficient amount of copper. And what that does is it further lowers the inductance of the driver, which translates to less distortion, a little bit better treble extension. And I would say those are the main developments in the new drivers.
John, what's the next new product we should expect from Classic Audio?
Pretty much accepted the fact that I've really got nothing new coming. I mean, unless some new technology drops out of the clouds that's going to give me something better. I mean, I'm always being asked to build a smaller speaker. I got big rooms at most shows. I'm going to have a big room at this show. Everybody expects me to have my big speakers in a big room, and I mean, I've done 8-inch full range. You know, they sound wonderful. You got to use them with a subwoofer. You got to put them in a large horn, bass horn, transmission line type of enclosure. I'm happy where I'm at.
Ken, will we be seeing this new driver in a new format?
Eventually, yeah. I mean, we definitely have ideas and other applications of the driver that would be interesting to us to pursue. The way I try to think about that when I've got my business hat on is I have to earn the right to solve future problems, and I would say that we made it to that point of having earned the right to come up with what is pretty close to a cost no object evolution of the field coil, and now we've applied it in the purest expression that we have of that, which is our single driver point source full range S1, which is what we're exhibiting here at the show, the S1X. And then the next logical step would be to confer that same benefit with some slight modifications that make sense into our S2, which is an open baffle application of the driver that shows off some of the beauty of it, which we don't happen to have here at the show, but we'll be taking to future shows as well. We also have entertained the idea of doing a genuinely cost no object loudspeaker for which that Apex driver would certainly make perfect sense. Some iteration that would be an S3 that would be truly a flagship product that could compete with anything regardless of format at the shows. But that's a problem we have not earned the right to solve. So in the future, I think you can look for future form factors and evolutions of the driver that make sense for us. But right now, we're so happy with the S1 and the S2. Absolutely wonderful reactions from attendees and the press. So I think we're like John. We're comfortable where we're at for a while. But in future years, you'll certainly.
I consider him the young blood of the industry.
Any questions for our designers? Please.
You find field coils are happier in loaded boxes, open baffles?
Well, from a thermal perspective, they're definitely happier in an open baffle. So when I sell a pair of loudspeakers, if they're the open baffle S2, I don't as stridently recommend that somebody make sure that at the end of their listening session, which can be as long as they like. Obviously, we run these at the shows for 12 hours or 16 hours, and for long periods of time in a closed box, and they only perform better and better. The metal expands, that gap gets tighter, and they just become better throughout the day. By the end of the day, they're oh man, they're really singing compared to how they perform in the morning. But with people who buy the S1, I still encourage them to turn the power supplies off at the end of the day and let that voice coil rest. Let the whole thing cool down. And what that's going to do is it's going to give you a longer service life for the loudspeaker. With the open baffle, I just kind of tell them, it's a good practice to do that. You should probably turn it off. And for the same reasons. But because it's in constant contact, that motor, with the air, it's much less of a concern than it is when it's in a confined place.
Have you done any measurements on what your driver heats up to open versus closed in, say, a 3 or 4 hour period?
I haven't measured what. No, actually, I did. And I think that in the open format, the hottest that it ever got last I measured it, and I think it's gone down since I last measured it, this was years ago, was like 122 Fahrenheit or something on the skin of the driver. And then the longest that I ever ran the S1, so closed, was I let it go for 4 straight days without turning it off. And then by the time that test was over, the cabinet was warm. The entire cabinet was warm, but it was nothing to be concerned about. And then I measured it, and it was, I think, 138 degrees Fahrenheit.
Oh wow!
So,
I've got 3 drivers in my enclosures, and my easiest way of checking temperature is to put a thermal and just shoot it into the throat of the wood horn. And I've never seen over 120 degrees at the end of a show day, which is from 9 a.m. till sometime 10, 11 o'clock at night.
right, and these are running much
right.
cooler.
And as he says, I've generally found that they have to be on. That's why I turn my system on at home 3 hours before I'm going to actually start doing any listening to it. And I very rarely listen to music when I'm not listening to music. I want to listen to music and I want to be focused. I'm listening to music when I do it. So I just don't play the thing for background music at all. Don't listen to radio. I can't. You find yourself you just can't listen to music any other way unless you're at a live event. But yeah, it does smooth things out. More focus, little nuances.
Yeah, and actually I should mention that when we have the open baffle running at the shows, I encourage people to touch the motor, to feel the warmth.
So it's cheating. It's out in free
air. but just to give you guys some perspective,
yeah.
It only reaches the point of being just pleasantly warm. It never reaches the point of being uncomfortable to the touch.
Any other questions?
With other companies adopting this technology, you mentioned AudioNote, Wolff on long run. How do you see your approach to design being different from those companies? I mean, do you actively kind of look at what they're doing? Do you see it as a great thing that it's being adopted?
Yes.
Or is there some cynicism around, it's just trending? I mean, how do you
Trending is great. I think that all boats rise with the tide, and so I'm delighted to see more companies getting on board with field coils and integrating them into their loudspeakers. That's nothing but good for John, good for me, it's good for the industry, and it's good for the listener, which really should be the point and focus of all of it. Everybody should be getting as good a listening experience as possible, and they should have as many great options out there available to them as possible as well. And as we believe, field coils are the best foundation.
Yeah.
So I'm delighted to see that. In response to your question about do I look at what they're doing? Oh yeah, absolutely. I'm very curious. For me, you know, I try to go into everything that I do in this with as much humility as I possibly can. And if other people are taking another approach that I think, you know, I stand to benefit from, or that is a corrective to a poor decision that I may have made and not realized I could have made a better decision with, you know, I look to my peers in the industry to see what they're doing. And hopefully they do the same with me. I would like to think that, you know, in the privacy of their own homes, they're on SongerAudio.com wondering what Ken Saunders,
What you're doing.
Yeah, what I'm doing, and if that's helpful to them, and we all, you know, have this kind of you know, interrelationship that we perhaps don't talk about, but we all benefit from. I think that's nothing but good for the industry.
Well, thanks very, very much for joining us. Thank you, Ken. Thank you, John. Thanks to Gary Gill and Lou Hinckley for hosting us.
And everybody's invited to both of our rooms.
John's speakers are amazing. They were an inspiration to me when I was
I
getting
will
started.
play your choice of music.
Thank you, everybody.